Hi guys, we're going to talk about the application of derivative in real life, and let's start with what is set exactly and where did it come from. So the first, before jumping in application of the derivative itself, we should look at what is derivative and where it came from. The derivative is exact rate of change at which one quantity changes with respect to another. Derivative is fundamental tool of calculus. For example, the derivative of the position of a moving object with respect to time is the object of velocity. This measures how quickly the position of the object changes when time is advanced. The process of finding the derivative is called differentiation. The definition of derivative. The most common approach to turn the intuitive idea into a precise definition is to find the derivative as a limit of difference quotients of real numbers. So let's take an example. So we're going to consider a function f of x that represents some quantity that varies as much as x varies. For instance, maybe f of x represents the amount of water in holding tank after x minutes. Of course, x doesn't have to represent time, but it takes, for example, that are easy to visualize. What we want to do here is to determine just how fast f of x is changing at some point, say x equals to a. This is called the instantaneous rate of change, or sometimes just rate of change of f of x at x equals a. So to compute the differentiation, derivative, we should turn to this example which I said before. So to compute the average rate of change of f of x at x equals to a, all we need to do is to choose another point, say x, and then the average rate of change will be as it states on the slide. So then we have to take the limit of this function, as we have to choose values of x that got closer and closer to x equals to a, and we plug this into the function. We also have made sure that we looked at values of x that were on both left and right sides of x equals to a. Eventually we should get the derivative of f of x with respect to x, like this one, and we also saw that with small change of notation, the limit could be written as instead of x, we should put x plus h, because small change, and we're just doing like that, and that's pretty much
Well,
it.
hi, my name is Ming, and now I'm going to introduce most popular abbreviation of derivative called optimization. And to introduce easier, I will take an example to show you how the derivative do. Firstly, we have a standard US can of soda which hold about 350 milliliters. And the problem here is find the dimension of the can. We'll use the least amount of aluminum. So firstly, we need to two primary equation. First is the surface area equation, and secondly is a volume equation. And from this, substitute it together, so we have the new equation of surface area, which based on R. Now after that, we will differentiate. So after that, we will take the derivative, and the first differentiate is in order to find the minimum of the stationary point, and the second one we can see here is always positive. So the stationary point when dr is 0 is a minimum point we need to find, and it's about 3.84 centimeter. And then substitute it into the primary, the second one, the volume equation here. We will have the h of 767 centimeter. So the answer here, the cylinder can will be the least with radius of 3.84 centimeter and the height of 760 centimeter. However, the real soda can is not exactly the cylinder, so this may not really exact. Example of the exact radius, the ratio is like the oil can we can see here.
I'm Kale, and now I will illustrate the derivative of derivative benefits for business and economists. Manager normally use it to calculate benefits cost to maximize the benefits for a firm. So firstly, I will show some information about marginal cost. Let's look at the example on the slide about question A. It means that the marginal cost between producing the 201st and 200th units. In another word, what we're looking for here is E200 EC of 201 minus C200, and we will get the answer equal 10.11. About the B1, it's as the range of trend, so I will derive CS and then substitute S equal 200 and get the result is 10. As you can see here, both the numbers are approximated, so we define the marginal cost function to be the derivative of the cost function. The cost function also contributes to calculate the average cost to the maximize firm's benefits. Here is a graph which shows the average cost function of the above example, and you can see that the average cost function has a minimum value. This minimum value will occur as a critical point when the average dash equals 0, because it is created by a blue horizontal tangent line. From the cost function, I got the average cost function equal CS divided S. We had a minimum average cost when cost average dash equals 0. Follow this step, we can say that the minimum average cost will occur when the average cost equals the marginal cost. Let's come back to the above example about finding the minimum average cost. Basically, I will derive CS, and I also have another solution for this equation. We will apply the consequence rule above. The marginal cost equals the average cost, and the final answer is similar with the first one here. And thank you for listening our presentation.